Showing, please.
I will just check.
It's not showing.
I have made you co-host, so you can.
Yeah, one.
You have to present your entire screen, I think.
Yes. Is it visible now?
Yes. It is presenting.
Let me open this.
Yes, I can see
Is
your
it visible,
screen.
sir? Is
Yes,
it
sir,
visible now?
visible. Yes, it is
Okay.
clearly visible.
Right. First of all, I would like to say sorry for the small interruption. So it's supposed to be start at 11:30. First, a very good morning, everyone, ladies and gentlemen who are present here. First of all, I would like to thank the organizers of short-term training program, Dr. Aparna and Dr. G.S. Garje for the introduction. They might have given, already they have given, introduced me to the audience. I'm very happy. And right, so coming to the presentation, the main purpose of this technical presentation and hands-on on optimization tools and techniques for electrical systems to familiarize you with the basic concepts of optimization algorithms in the power systems and help you to understand the potential of optimization in the power systems. And right, so further we will also be exploring a basic concepts of optimization routine, which includes how to select an optimization algorithm for a problem, the initialization of optimization process, and the mathematical modeling is very, very important in most of the cases, how to do the mathematical modeling of a problem, and the formulation of the cost function or the objective function. Later, we will cover the interpretation of the results of the problem which we are going to take, and the comparison of the results of the considered algorithm with the other techniques. So these things will be covered. Okay. So first of all, the presentation has been divided into 4 parts. The first part would be covering the basics of optimization. As you all know, already I have gone through the schedule of this particular short-term training program. So the previous resource persons have already covered the basics of the optimization, and they have already covered some of the swarm intelligent algorithms and other optimization, meta heuristic optimization algorithms. They applied to some PV parameter estimation and some other applications. So I won't take much time in the basics of optimization. I will rather I will cover one important application, that is the real world application, that is in the power system. Basically, I am going to take one problem related to the power system, that is IEEE 30 bus system, and we will discuss in detail how to implement a MATLAB code for one meta heuristic optimization, that is SGO, social group optimization, how it can be used to find the better solution of this power system. And later there will be a conclusion. So in the second part, just we will explore the function of 3 important optimization algorithms like particle swarm optimization, genetic algorithm, and differential evaluation. These are the classical paradigms. Many researchers have done research on improvement of these classical paradigms to get the better solutions of various complex problems. In the third part, there will be a detailed discussion on how to implement the MATLAB optimization for a well-known problems in a power system, that is optimal power flow. Finally, in the last part, we will discuss the future aspects of the algorithms and so on. And at the end of the presentation, we have provided the links of the original research of the various algorithms and their MATLAB codes for your convenience and the perusal. So coming to the basic things, I would like to ask one or two questions based on the optimization, because many of the audience have already gone through the presentations given by the resource persons. So optimization, basically the optimization, how it is important for the engineers. What is your opinion? How it helps the engineers, how the optimization helps the engineers? Can anyone answer? I will be very happy.
It helped in reducing the cost while designing or
Exactly,
increasing the
exactly.
efficiency of the overall system.
Exactly. Very good. So basically, the optimization is the process of finding the conditions that give the maximum or minimum value of a function. So that means obtaining the best result under given circumstances. There may be limitations and constraints in the design. So basically, we are all engineers. So we take many technological and managerial decisions at several stages in the design, construction, and maintenance of any engineering system. It may be an electrical system, mechanical system, any system you take, the engineers have to make many technological and managerial decisions in every stage of design, construction, and the maintenance. So, what may be the ultimate goal of those decisions? So, the ultimate goal of those decisions is either to minimize the required effort or to maximize the desired profit. So, this is the role of optimization in any of the engineering systems. So, the engineers have to use many of the optimization techniques to deal with complex problems in the real world. So this is just a definition of the optimization. So the optimization is the process of finding the conditions. So that means the solutions of the problem that give the maximum or minimum value of a function, means that is the mathematical model of the problem what we consider. So coming to the applications part. So they basically definition of optimization just now we have seen. There are various complex functions like f of x1, x2, x3, xn. If you see there is a function, it is a complex function which is non-differentiable function. And there could be millions of combinations of these variables. That means the solution may be could be any combination of these variables, but it is very difficult to find the solution or the optimum combination of these parameters like x1, x2, x3, x4, or so on, xn. So the numerical methods, if the function is not differentiable, if the function is nonlinear in nature, many of the numerical methods and many of the approximation methods, they fail to give the better solution. So that's why there is a need of modern or meta-heuristic algorithms to solve very complex problems, which are represented by the complex functions like f of x1, x2. The function may be linear in nature or nonlinear in nature. The variables, there are various constraints associated with this function. So this is the role of optimization. So basically, there are various optimization techniques. So these are the various applications of optimization. Just it is very clear that what is optimization so far. So there are various applications. Optimization has become widespread across various disciplines of engineering and science. So this particular slide shows a few areas where optimization has been prominent. So like in agriculture, people use optimization. In the space sciences, in various applications, nowadays people are using in computer science, that is in artificial intelligence and machine learning, people are using optimization algorithms. Okay. So coming to the basic terminology, this is all, I think this you are all familiar with these terms used in the optimization process. Basically, in order to implement any optimization process, you must thorough with these terms. Optimization, that is objective function. This is also called fitness function. So basically, for any problem to be optimized, that means to get the best solution of any problem, we must model the problem. So it is the mathematical representation of the problem that is called objective function. It may be a maximization. The function can be maximized or minimized depending on the requirement. And there are several variables associated with the objective function. So these are the variables called decision variables. The decision variables are to be optimized. So we have to get the optimal combination of these decision variables to minimize the function or the maximize the function. In most of the electrical systems, we use the minimization problem. So we have to minimize the cost of the system. So we have to, if it is maximization problem, then we have to formulate the objective function accordingly. And every decision variable must be limited with lower value and the upper value. Those are called lower and upper limits of the particular decision variable. And these things will be clear when we discuss a IEEE 30 bus system, that is the optimal power flow problem. So there are various constraints. Without constraints, there is no problem. There is no design. Under some constraints and the limitations only, we engineers usually design and construct the system. And for every problem, there is a feasible solution and optimal solution. The solution is said to be feasible if it satisfies all the constraints what we considered at the beginning of the problem. And the optimal solution means it is the optimal feasible solution which satisfies both equality and inequality constraints. So these are the some of the terms we must know before entering into the optimization process. So basically, if you see, this is the methodology of optimization. So in the optimization, the first step is to identify the problem, whether the problem is the constrained problem or unconstrained problem. That is the identification of the problem. For example, we are going to take the IEEE 30 bus system, so which is a part of the power system. The area of specialization is the power system. In the power system, we are going to take the IEEE 30 bus system. So the main objective of the optimal power flow problem is to minimize the fuel cost, minimize the emission, and to minimize the voltage deviation. And there are various objectives we can formulate. So whether that problem is constrained problem or unconstrained problem, that is the identification. And whether the decision variables, on what variables the fuel cost depends. Basically, in the IEEE 30 bus system, the fuel cost mainly depends on the output generation of the generators connected at various nodes or the buses of the system. So what are those decision variables? Whether those decision variables are continuous in nature or integers or binary. Whether those variables are time varying or static one. So in this way, the problem identification is the first step involved in the optimization process. Later, if you see, the second step is deals with the complexity of the problem. So the complexity means in terms of mathematical modeling. So in what way the mathematical model is to be formulated. So the mathematical model in the sense formulating the objective function based on the mathematical model. So while formulating the mathematical model, if the mathematical model consists of many decision variables to be optimized, then the complexity automatically increased. Okay. So the number of iterations take the more time. That means the computational time will increase. So whether the complexity of the problem is less or more, that is also we have to consider while optimizing the process or problem. And the third important step is we have to make sure that we are dealing with the right mathematical model with the accurate problem data. So every problem has some data. That data is to be utilized properly for modeling the problem. So if the objective function is not properly modeled, if you take the inaccurate data, imprecise data for the modeling, that may lead to the inaccurate results, that may lead to the bad solutions. We may not end up with the best solution. So the formulation of the mathematical model of a problem is very, very important step in the optimization process. That means in order to apply any optimization algorithm, the mathematical modeling of a problem is very, very important. And then in the fifth step, if you see, verification. The mathematical model, whatever we formulate, must be verified properly. So by giving the known inputs, we have to check the outputs of the mathematical model. So for the known inputs, whether we are getting the proper outputs or not, we have to check. So whatever the mathematical model, that means nothing but the formulation of the fitness function. Whatever the fitness function we are going to formulate, that must be proper or accurately related with the problem. And it must be verified. If it is not verified properly, if the mathematical model of a problem is improperly modeled, that may lead to the bad results. And then we have to apply the application of the algorithm. So once the mathematical model is formulated, the next step is the application of the optimization algorithm. There are different types of optimization algorithms. That categorization we are going to see in due course of time. So which optimization algorithm is to be selected? So the selection of optimization algorithm is very, very important for the problem to be considered. So after application of the optimization algorithm, we get the results, like we get some solutions of that particular problem. So those, since if the optimization is stochastic in nature, we get the different solutions at every time. So we must perform the statistical analysis for the results of the optimization algorithm. So after statistical analysis, those results are to be compared with the other optimization algorithms for the validation. So these are the steps involved in the optimization process. Hope this is clear. Am I going in a correct pace?
Yes, sir.
Yeah. Thank you. So coming to this optimization routine logic. In optimization routine, the optimization algorithm improves the solution in steps or iterations until a specific level of the solution quality is attained. If you see here, there is an optimization algorithm or solver. There are three important steps. The routine starts, the optimization algorithm starts with the initialization, wherein the problem specific details, such as we have to give the dimension, what is the dimension of that particular problem. These things will be very clear when we take the problem. So that is the IEEE 30 bus system. So we must take the dimensions. How many variables are to be optimized related to the problem? That is the dimension. And we have to give the lower and upper bound values of those decision variables. And how many number of iterations, how many times we have to execute the entire program. That means that particular code, that is the number of iterations. So the iterations can be given, that is as a termination criteria. So suppose if you select the number of iterations as 100, then after 100 times execution, the optimization algorithm will be stopped. So, and NP, so the number of population size, that means the population size means the number of solutions to be present. So after initialization, once the optimization algorithm usually consists of search methodology. You can see here the optimization algorithm consists of search methodology, and there are some tuning parameters in every optimization algorithm. So the search, based on the search methodology, there are different types of optimization algorithms, right? So the search mechanism is very, very important point to be noted. So people use different search mechanisms. The search mechanisms depends, inspired by many things, like inspired by the particle swarm, that is human behavior inspired. So that is the search methodology we use in the optimization algorithm. And control parameters, there are different tuning parameters or the control parameters to be selected, based on which we get the solutions. And the termination criteria, it may be number of iterations we can select, and the number of the value of the error can also be selected as a termination criteria. So this all happens through some mathematical model of the problem. The mathematical model can be formulated based on the data and constraints. So by using the problem data and constraints, we formulate the objective function. So you can see here, this optimization algorithm interacts with the mathematical model of the problem, and to substitute the solutions into the objective function or the fitness function to obtain the fitness values. And this loop repeats itself until a certain termination criteria is reached. Suppose if you satisfy with the solution, then we can stop. If we are not satisfied, we can run the optimization algorithm again. So this is the basic steps involved in the execution of the optimization algorithm. So this particular slide gives you the information about the different types of optimization algorithms. So like approximation methods, numerical methods, stochastic methods, the differences among these three categories are given very clearly in the slide you can see here. The first type is calculus-based approximation methods like Newton-Raphson method, Gauss Seidel method. These are the approximation methods. These all methods rely on the differential information. Whatever the function to be optimized, it must be differentiable. Then only we can get the feasible solutions. If the functions are not differentiable in nature, then we have to go for numerical, either numerical or stochastic methods. So depending on the nature of the function means the problem, that problem must be mathematically represented with one function. So if the function is differentiable, then only the approximation methods are suitable. If the functions are not differentiable, then we have to go for either numerical methods and the stochastic methods. So if you see the comparison, the approximation methods have the problem of slow convergence. So it takes a lot of time to give the solution, and there is a curse of dimensionality. Suppose if the number of decision variables of a function increases, then the approximation method may fail to give the good solution. That is the curse of dimensionality. Whereas in the numerical methods and the stochastic methods, like which we are going to see now, that is the meta-heuristic optimization, comes under stochastic methods, which have high immunity to curse of dimensionality. So that is the main advantage of stochastic method. And another advantage of stochastic method or meta-heuristic optimization methods comes under this, have the faster convergence and moderate computational times and computationally moderately expensive. You can see these are all the advantages of meta-heuristic optimization algorithms compared to the numerical and the approximation methods. So for example, in the numerical methods are problem specific. If the function is linear in nature, if the constraints are linear, then only the linear programming can be applied. Linear programming method cannot be applied to the nonlinear functions or the function having nonlinear constraints. Okay, so like that, the numerical methods are problem specific, but the stochastic methods are not problem specific. This can be applied to any problem. So this can be applied to any problem in the sense broad applicability. So these are the some of the advantages of stochastic methods over approximation and numerical methods. So now we are going to discuss how do electrical systems benefit from the optimization. You can see here the role of stochastic optimization algorithms have been significant in electrical and its associated systems. Like this is because most electrical systems are known for their extreme complexity and have numerous variables to be optimized and constraints to be satisfied. So most of the electrical systems, like power system is one type of electrical system in various domains already present in the power system. Again, electrical systems, renewable energy, reactive power dispatch. There are various domains again, wind, solar power, wind power. There are various domains again in the electrical system. In various domains, whatever the problem you take, those problems are very complex in nature, which are non-linear in nature. There are many constraints to be deal with. So that's why we can consider that electrical system, the problems related to the electrical system are very complex in nature. So whatever the new approximation methods and numerical methods we have seen in the previous slide, they fail to give the better solutions when we apply to the electrical system related problems. So that's why there is a need of meta-heuristic optimization to be applied to the electrical systems. So if you see the graph shows the growth in the application of stochastic optimization algorithms over the last decades from 2001 to 2021. If you see, there are 25,000 documents have been contributed to the renewable energy optimization. So this particular slide shows that the role of optimization people have applied to various electrical systems. So around 25,000 documents have been authored and published by various researchers. So various subdomains of optimization in electrical system. Within a renewable energy in the power system, optimization is extensively researched for wind, solar, hybrid systems, and hydropower as well. So to be specific, grid integration of renewables and optical scheduling are in good standing, and role of optimization in these subdomains continues to increase. So if you see here, there are various subdomains of the electrical system where the people have applied the optimization algorithms. So the previous slide and this slide gives us the information about the role of optimization in the electrical systems. So this is about the optimization, the role of optimization and the importance of optimization in the electrical systems. So now the second section mainly deals with the most commonly used optimization paradigms like PSO, genetic algorithm, and differential evolution. I hope you have already learned from various previous resource persons how this PSO works and how the genetic algorithm works and how the differential evolution works. Okay, so just for the time being, just you can see these are all the meta heuristic algorithms. So these are all things comes under meta heuristic algorithms. If you see here, the working of any meta heuristic algorithm starts with the initialization. So I will clearly explain how the meta heuristic algorithm can be initialized with respect to one of the algorithms. So in general, any meta heuristic optimization algorithm starts with the initialization. So initially we have to give the dimensions and the number of population, that means the population size and the number of iterations. So later a set of based on the number of iterations, we get the number of solutions. Initially we will get the number of solutions that is equal to the population size. Each solution of that particular initialization vector is called population member. So within the lower and upper bounds, the initialization vector is generated. So after the generation of the initial solutions, those solutions are substituted in the fitness function, the fitness evaluation function. So that means the fitness that is called cost function. In the cost function, every initial solution is to be substituted. So later, the fitness function is to be evaluated. The value of the fitness function is to be calculated. Suppose if the problem is minimization problem, then we have to see which population member gives the minimum fitness value. So accordingly, we can select, we can use some search algorithm to find the new population size. So initially there will be a population member, that means the initial population vector, and later the population vector is to be updated based on some search mechanism. That is very, very important. What search mechanism we are going to use in the optimization algorithm? Based on this, optimization algorithms are classified into many. In the particle swarm optimization, the velocity, the movement of the particles, every particle of the PSO is considered as a solution. With what velocity the particles are moving towards the target, that is the velocity. So the updation, the positions of the particles are to be updated by using some equation, that is a search mechanism. The search mechanism is formulated with equations. So those are called velocity equations in the PSO. So in every iteration, the fitness of the solution improves gradually. So what is meta heuristic algorithm? So the meta means, as you see in the slide, it is a higher order. Heuristic means the process of self-discovery through some random search mechanisms. So the meta heuristic means higher order self-discovery process through random search mechanism. So that random search mechanism is very, very important. What kind of search mechanism we are going to use in the optimization algorithm? Based on that, the meta heuristic optimization algorithms are categorized into many. Okay. For example, I am going to consider one meta heuristic optimization algorithm in this presentation, that is social group optimization. In the social group optimization, the search mechanism would be the interaction of the people among themselves. So in a social group, in a group of people, the group of people have the different knowledge levels. So when they interact, they share the knowledge from each other. So that particular mechanism is used to change the positions of the solutions in the search mechanism. So that means the human behavior inspired algorithm, that is a social group optimization that we are going to discuss in detail. So in general, based on the random search mechanism only, the meta heuristic algorithms are classified into many. So this is the classification. This is the one of the classification. There are many more classifications given in the literature. You can see here, evolutionary based algorithms, trajectory based algorithms, nature inspired algorithms, ancient inspired. So what is inspired for implementing the search mechanism? Based on that, the meta-heuristic optimization algorithms are classified. For example, nature inspired. Particle swarm optimization comes under nature inspired optimization algorithm. And gray wolf optimization, whale optimization, human behavior inspired algorithms like a teaching learning based algorithm and the social group optimization. These are all things comes in nature inspired. That means the optimization algorithms are categorized based on the search mechanism what we use. Okay. So why these many meta-heuristic algorithms come into the picture? So many fancy names are people are giving like Jaya algorithm and Tabu search algorithm. There are different names given to it. So basically, one meta-heuristic algorithm cannot perform well for all the problems. So that we have to keep in our mind. So one meta-heuristic algorithm cannot be used to solve all the problems. So that means there is no free lunch theorem. So that's why people are researching various meta-heuristic algorithms depending on the problem. So, and the people are implementing the different meta-heuristic algorithms based on the different search mechanisms for solving the benchmark problems, for solving the problems in hand. It may be the problems may be related to the electrical system, the problems may be related to any discipline what I mentioned earlier. It may be related to agriculture, it may be related to science. So depending on the complexity and the nature of the problem, people are developing the meta-heuristic algorithms, and people are mostly people are relying on the classical paradigms like particle swarm optimization, genetic algorithm, and other differential evaluation and the variants of them. So that's why the meta-heuristics people are developing year by year. The meta-heuristic algorithms people are developing many algorithms based on the problems. So which algorithm is to be selected? This is also very important. So just if you see here, which algorithm is to be selected? So there are various classical paradigms, as I mentioned. So the variants of GA, PSO, and DE can be considered for the algorithms. Okay. So there is a popularity, huge popularity of these three algorithms what I mentioned: genetic, PSO, and differential evaluation. So if you see the graph from 2000 to 2020, there are various publications. The various people have done the research in their domain, and they have applied the genetic algorithm and their variants to solve their problems. And PSO also, people have used the particle swarm optimization to power system related domains like electrical vehicle and reactive power dispatch. In various domains, people have used the particle swarm optimization. So there is a popularity of classical paradigms, even though the newer meta-heuristic algorithms have been emerged. So this is the PSO. Just you can see at a glance, the PSO, it was developed by James Kennedy in the year 1942. So there are only simply 4 steps involved in the PSO. The working of PSO includes the initialization of the population. Population is the size. So initially we consider the number of solutions of a particular problem. So out of those many solutions, we have to select the best one after updating the population. So the population, that means the number of solutions, whatever we consider are to be updated based on some search mechanism. Here, that is the velocity updation, you can see here. So here in PSO, every solution is treated as a particle. So particle, that may be a bird or fish, and it searches for a new solution for the new population through the movement in a set space. So that movement is attributed with the velocity. And if you see here, the velocity update, it consists of three important components: inertial component, cognitive component, social component. So these three components are present in the velocity equation. By properly selecting the inertial component, cognitive and social components, we can achieve the better solution. So the position update is given in the next equation. And once the position is updated, next we will get the new population members, and the fitness of that particular every member is to be calculated, and we have to find out the best solution, whichever the member is giving the minimum fitness value. Based on that, we can select the best values. So there are three tuning parameters in the PSO, that is inertial weight, cognitive parameter, social parameter. Apart from population size and number of iterations, it should be same for all the algorithms, whereas the first three parameters are the tuning parameters of the PSO. By properly tuning these three parameters, one can achieve the better solution for the problem to be tackled. So this is just the working of PSO, you can see. So all the particles, initially all the particles are at random positions. So there is a target at the center. So after changing its velocity, it is reaching to the, all are converging at one place. So this is a global minimum of a function. So genetic algorithm, just I am skipping this genetic algorithm now, because already this is a basic algorithm you might have already learned from the previous resource persons. So this is the genetic algorithm, and differential evaluation is also having two tuning parameters, that is crossover probability and scaling factor. So right, so how complex can optimization problems be? So optimization problems are very complex in nature. So they have many local minima and maxima, you can see here. So these are the surface plots of a few of the complex problems. The two images on the right are the variations of the Skiffel function, known for its extreme levels of complexity and multimodality. If you see here, there are various peaks and crests of this function. So any algorithm may trap at local minimum. So it has many minimum values and maximum values. So this is the surface plot of one complex problem. So that's why there are a lot of local optimal points intended to trap the algorithm from fully exploring the other regions. So in the modern meta heuristics, it has been observed that they are very easily trapped into some local regions in these complex functions. So in most cases, these results are often not published, and simpler landscapes are prioritized. So the complex problems are represented in these with these things. Okay. So coming to the application of meta heuristic optimization algorithm in power system. So this particular section, in this section, we will implement a hand-on of application of a simple human behavior inspired optimization algorithm, that is called social group optimization, for the problem to be considered in the power system. So this is the content of the third part of this presentation. Just we will see, so far just we covered the basic things only. Already you might have already learned those things from the previous sessions. So from this session, from this part or the section onwards, it is very important to note. So first I will explain you how the power system is to be modeled by using mathematical equations. Later we will quickly go through the working of social group optimization. There are 6 steps involved in the social group optimization. I am going to cover those things, and later I will show the MATLAB code how to implement the social group optimization and how to model a particular problem taken in the power system domain. And later I will show the results of the social group optimization, and in comparison with 4 more algorithms, that is genetic algorithm, particle swarm optimization, Gray-Wolf optimization, and differential evolution. So then only we can come to know the importance of that particular social group optimization, how it performs, the performance of the social group optimization over other algorithms. So basically the power system, if you see here, any power system is the network of various electrical components used to supply, as you all know. Being an instrumentation engineer, I have very limited knowledge in the electrical domain, but I have sufficient knowledge to explain whatever required in this presentation. So basically, as you all know, because you are all electrical engineers, you all know what is power system. So there are various electrical components involved in the power system, which are used to supply and transfer and consume the electric power. So in power system, there is a generation, as you know, distribution and transmission. So simply the combination of these three things can be considered as power system. So first there is a power generation. So you can see this particular slide. There is a generating substation. There are various generators. Then it's a transmission through step up and step down transformers. And finally, the distribution to the loads at a local level. So these are the various basic components of the power system. So what is the role of optimization in this particular power system? Can anyone tell me, please? So what may be the role of optimization in the power system here? Because these are the various components, you know what is the importance of each and every stage or the component of the power system. As I mentioned, there are some generators which are used for supplying the power. There are some step up and step down transformer which are used to transmit the power from generating stations to the loading centers. And there are some distribution lines which are used to give the power to the local or nearby homes or the industries. So there are various components involved in this power system. So then what may be the role of power system here, optimization here? Can anyone answer, please? I will be very happy. What is the role of optimization in these all components of the power system? This is the real world problem. Now we are getting the power from generating stations through transmission lines. So what is meant by optimization of the power system?
So getting maximum power.
Getting maximum power, okay. Okay. Fine. So what is meant by optimization in the power system? Means it is all about the identification of various parameters to be optimized. What are the parameters to be optimized in the power system? That is to be, because as I mentioned in the previous slides, first we have to identify the problem. In order to apply the optimization algorithm, first thing is there are two important things. First, we have to identify the problem. We have to see the nature of the problem, whether it is a constrained problem or unconstrained problem. The second thing is selection of optimization algorithm. Every algorithm requires the mathematical model of the problem. In order to formulate the mathematical model of a problem, we must know the nature of the problem. So if you see here, this is the power system. It composes many elements. So what are the parameters to be optimized? We must know. So such that the undesirable things are kept at minimum. So what are the undesirable things that may occur in the power system? Fuel cost. The fuel cost is the one parameter which is to be minimized. And there is a loss from the generating to the distribution because the power passes from the generating station to the distribution substations. So in the transfer of the power, there is a huge loss, power loss, reactive power loss, real power loss. There may be loss of because of the transmission lines, and there are various factors behind it. So the power loss must be minimized. So the objective, I am going to formulate the mathematical model based on these objectives. The first objective would be, in the power system, the first objective would be, we have to minimize the fuel cost under some constraints. Those constraints also we will see related to one system. And we have to minimize the power loss, and we have to minimize the errors associated with the various components of the power system, while the desirable aspects are to be maximized. Just now, so far I mentioned the minimization things. There are some things which are to be maximized. The profit is to be maximized. The quality of the power is to be maximized. The efficiency of the total system is to be maximized. It should be, we have to make the system more economical. What is meant by optimization of the power system? Optimization of the power system is meant by to make the system more efficient. to make the system more qualitative. So that is nothing but the optimizing the system to get the better results. So this is the just basics of the power system and its components. So if you see here, power system optimization, as I mentioned, there are some undesirable things and desirable things. Undesirable things means we have to minimize the cost, energy loss, that is power loss, and the errors. And we have to, there are certain things which are to be maximized related to the power system. So we have to improve the efficiency under some constraints or some circumstances. This is very, very important. So there is no design of the power system without constraints. So always in the design of every system, there will be some limitations or the constraints. Under those constraints, the system must be optimized. So there is a huge need of optimization in the power systems for the effective fuel utilization and lowering the fuel costs. There are various generators. We use gasoline generators and thermal generators. We use various fuels, single fuel, we can use multiple fuels people are using. So effective fuel utilization is very, very important point to be noted in the power system. So for effective fuel utilization and the lowering fuel costs, optimization plays a very, very important role. In order to improve the voltage stability of the power systems, we use optimization. In order to increase the system security, power outage times, to reduce the power outage times, to reduce the faults occur in the various locations of the power system, we use the optimization. So optimization plays a very, very important role to achieve many objectives, whatever given here, so that we can save millions of revenue on the annual basis. So ultimately, optimizing the power system saves a lot of money. Okay, so this is the very important thing. So how complex the problems in the power systems? So again, the nature of the problem. So the problem may be linear or non-linear, but most of the problems which are considered in the power system are non-linear in nature. So if you see, the linear means there may be only one minima and maxima, but in the non-linear, the right side of the slide, if you see, there is a non-linear nature of the problems. There may be more than one minimum and maximum values of the function. So the optimization algorithm, when we apply, it may trap it at the local minimum instead of getting the local minimum, global minimum. Okay, so that's why when the problem is of this kind, non-linear and multi-modal problems, then we have to be very careful while applying the right algorithm to get the best solution of this kind of problems. So these are the complexity of the problems in the power systems. So actually, we are going to consider the optimal power flow problem. So actually, we considered along with my research student, the research student has done all these. He considered the different cases of the power system. He has taken IEEE 30 bus system. This is he considered the 9 cases with different objectives. In the first case, he considered the fuel cost. He minimized the fuel cost of IEEE 30 bus system. And in the second case, he considered only the voltage stability, maintaining the voltage stability. In the third case, he considered the emission, minimizing the emission of the various components present in the system, and minimization of the power loss. And whereas in the fifth case, there is a multi-objective. First objective is minimization of the fuel cost by considering the wall point effect. In case 6, he considered the minimization of both minimization of the fuel cost and the power loss, minimization of the power loss. In 7th case, he considered minimization of the fuel cost and minimization of the voltage deviation of the various bus voltages and the load bus voltages and generator bus voltages. And in case 8, he considered both minimization of the fuel cost and voltage, maintaining the voltage stability in the entire bus system. And in case 9, he considered 4 objectives. You can see here how many objectives are to be taken related to the system. So in the optimal power flow, optimization is tackled in 9 cases, you can see here. So the 9 different cases are provided in this slide. So cases 1 to 4 deal with single objectives, and the rest of them are multi-objective cases. dealt as a single objective cases through a weighted factor method, right? So the constraints include the various equality and inequality, like including power balance, generation, and distribution limits, security constraints that I am going to show for one case. So just I am going to take only one case of this particular optimal power flow problem. So there are various types of buses you might have studied in the power system, as you all know already. There are swing bus, which is the reference bus, whose magnitude, voltage magnitude, and phase angles are specified, but real power and the reactive powers are unknown. Whereas the generator bus, in which the reactive power and the only real power is specified, whereas the phase angle is not specified. So in the load bus, where the voltage and the angle related with the four important quantities: magnitude of voltage, phase angle of voltage, active power or true power, and reactive power. So this is about the bus system. So this is a IEEE 30 bus system. So this is the problem we are going to take. So before entering into the system, problem, you must know what is this IEEE bus system. So here, in this figure, the circles, there are 30 nodes or 30 buses here in this system. The circles represents the generators. The generators may be thermal based or gasoline based. The downward arrows represent the loads, and the horizontal bars denote the nodes connecting branches. So these are the branches, the lines which are connected between the horizontal bars. So that means in this IEEE 30 bus system, basically many researchers have used the IEEE 30 bus system to do their research to tackle the problems such as economic power dispatch, reactive power dispatch, loss minimization. Actually, this was used in the American electric power system. They have proposed IEEE 30 bus provides an approximation of standardized power system network. So this is the standard network which is already available in the literature. People are using this IEEE 30 bus system for their research work. Okay. So there are some specification description of the IEEE 30 bus system. There are 30 nodes, as I shown in the previous slide. There are 41 branches. Branches means the lines which are connecting between the 1 and 2. Between 1 and 2, there is a line which is connected. This is called branch. So there are 41 branches in this particular IEEE 30 bus system, and there are 6 generators, out of which one is the swing or slack bus, and the generators are connected at the 2nd, 5th, 8th, 11th, and 13th nodes of the bus system. And there are 9 shunt volt ampere reactive compensation net devices, like capacitor banks are connected at these locations. So 10, 12, 15, this is about at these nodes, these shunt compensation, that shunt VAR compensation devices are connected for the reactive power. So there are 4 transformer with tap changers are connected at the branches 11, 12, and 36. And there are 24 controlled variables. I am going to show what are those controlled variables. And the connected load is assumed as 283.4 megawatt, and the reactive is 126.2. So the bus voltage is to be maintained between 0.95 to 1.05 per unit. If the basic voltage is 220, then the bus voltages are to be maintained between 215 to 225 volts. So that means there are 24 decision variables of this particular problem. So this IEEE 30 bus system problem is to be modeled as a 24 dimension. That means there are 24 variables would be present in the mathematical model of the problem. So these are the various objectives. I am going to take the first objective, minimization of the fuel cost. And what are these 24 variables I am going to show here? So there are 24 variables we considered which are to be optimized. The main objective of this particular problem is to minimize the fuel cost. First objective only I am taking. There are 9 cases considered, but first case is how to minimize the fuel cost, what combination of these variables are to be taken to minimize the fuel cost. So there are the first 5 variables are related to the active power generation limits of the generator. So there are 5 generators. One is the reference generator whose power is known to us. So the first generator, for example, if you take the generator 1 which is connected at the second node of the IEEE 30 bus, must generate the power between 20 and 80 megawatts based on the load. And the second generator supposed to produce between 15 and 50 megawatts. So like this, these are the active power generation limits of the 5 generators are taken as a decision variables. We have to optimize at what value of this power we will have the perfect power fuel cost, minimized fuel cost with more efficiency, with load distribution, uniform load distribution. And the voltage magnitude limits of the generators are given here. It lies between 0.95 to 1.1. There are 6 generators. The generator is supposed to generate the voltage between, if the basic voltage, if you take 220, it should be in between 215 to 220 volts. So these are the limits we have to take. So for every decision variable to be optimized, we must give the lower bound and upper bound values. These values are already given in the research papers for the IEEE 30 bus system, because these are all not new. For IEEE 30 bus system, these are the values already specified. Whereas the reactive power limits of the shunt compensators are between 0 and 5. If there is no load, there is no reactive power. If there is a full load, then the reactive power may go to 5 MVA. And this is the tap changing transformer limits. So there are 4 transformers connected. The turns ratio are given between 0.9 to 1.1. So these are the 24 decision variables we have considered in this problem. So the objective would be here, we have to find the 24 optimum values between these limits. So if you see here, 2.75 into 10 power 12,187 combinations would be present between these limits. So you can see how big this number is. So we have to find out the optimum 24 values between these limits. Suppose if you take 2 decimal places for this first 5 values. So 20.01, 20.02, 20.03 up to 80. So 15.01, 15.02 up to 50. So if you calculate the various values in between these 5 limits, and for the voltage magnitude limits, the number would be 2.75 into 10 power 12,185. Out of all these combinations, we have to take one combination which is to be optimized. It's very difficult for the numerical methods and the approximation methods to find out the best combination out of many combinations. So that's why we have to go for meta-heuristic optimization algorithms to get the best combination or the best 24 values between these limits. So that is the minimization of the cost, and these the limits, upper bound and lower bound limits are given here. Minimization of the fuel cost is the objective. So with this, we are going to formulate the mathematical model of the problem. I hope the problem is very clear to you. So what is the objective of the problem we are going to consider here? Can anyone please answer?
Minimize the fuel cost.
Exactly. So we are going to minimize the fuel cost. For that, what we have to do, we have to find out the optimal parameters. So whatever the 24 parameters, decision variables taken here, we have to find out the best 24 values in between these limits, such that the fuel cost of the IEEE 30 bus system is minimized. So actually, in general, the optimal power flow problem is represented by the quadratic equation, that is f of x comma u. So subjected to some inequality and equality constraints. Okay. So this g of x comma u represents the inequality constraints. H of x comma u represents the equality constraints. So this x represents the dependent variables. U represents the independent variables. So this f of x comma u is the fuel cost that I am going to formulate. This is the in general representation of the fuel cost. Right. Now, if you see here, this is already given in the research paper. So the relationship between the fuel cost and the generated power. Basically, we have to find out what parameters depends on the fuel cost depends on what parameters. Basically, the fuel cost of the IEEE 30 bus system, the fuel that is to be consumed by for the generation of the power depends on the power generated by the generators. So if you're able to optimize the generated power such that the uniform distribution, load distribution is present, we have to minimize the fuel cost. So this fitness function, this is called a mathematical model or the objective function, whatever. So minimization of these parameters, like if you minimize the generated power, then automatically we can minimize the fuel cost. That is the meaning of this one. So if you see here, there are a few coefficients here, cost coefficients. AI, BI, CI are the cost coefficients of the 6 generators. So we can consider only 5 generators here. There are 5 generators as you have seen in the IEEE 30 bus system. AI, BI, CI are the cost coefficients of the generators. PG represents the generated output power. So the sum of all these things gives us the function. So you can see here. So by seeing this expression, you can say that this is not the linear function. This is the quadratic function. Okay. And this is not the simple problem. This is not a simple problem. It is a constrained problem. We are going to consider the constraints also. So when I expand this function for 5 generators, A1 plus B1 PG1 plus C1 PG1 square plus A2 plus B2 PG2 and so on. If you see here, A1, B1, C1 are the cost coefficients of each generator. These values are already given in the literature. These values can be directly used in our program while calculating the fitness value of this one. So this is very important to find the fitness value of this function. This is called a fitness function or the objective function to minimize the cost of the given problem. So this is the formulation, and lower bounds are also mentioned here. And the first 5 variables are responsible for minimization of the fuel cost, whereas the 19 decision variables, other decision variables, which we are not going to optimize, because we are the objective what we formulated here is to minimize the fuel cost. Basically, the fuel cost mainly depends on the output power generated by the generators. If you optimize the output power of the generators, automatically the fuel cost can be minimized. Whereas the 19 other decision variables what we considered that are responsible to minimize the emission, to minimize the voltage deviation, to minimize the power loss, and they can be considered as the secondary objectives. Okay. In the first case, we are going to optimize the first 5 decision variables, that is PG1, PG2, PG3 up to PG5, as per the algorithm what we are going to apply. So this is the detailed details of the equality and inequality constraints of the optimal power flow problem. Okay. So the first one is the power balance equation. By using the power balance equation, there are 2 equality constraints. These equality constraints represent the generated power equal to demand plus losses. The generated power must be equal to demand per losses. In the reactive power generated equal to reactive power demand plus losses. So in any power system, that means in the IEEE 30 bus or IEEE 55 bus, whatever the bus you take, the generated power must be equal to the demand power plus the losses. That is the constraint. Okay. And there are some constraints on the generator, which is the one of the components of, as we have seen in the power system is composed of various generators, transformers, shunt compensator devices, and etc. So whatever the components present in the power system, that is generator is the one of them. The generator output voltage must be within the limits. So that is V minimum, that is V maximum. So the generator output voltage must be within these limits. And the generator output reactive power, that means real power must be in between PG minimum to PG max. And the reactive power must be in between Q minimum to Q max. So whatever the powers and the voltages related to generator must be in these values. This minimum and maximum values are already given for the various generators present in the IEEE 30 bus system. Remember, we are not going to define these minimum and maximum values. All these values are already available in the literature. V minimum and V max, P P minimum and P max, Q minimum and Q max. P minimum is real power, Q is the reactive power. Real power and active powers are already given for the IEEE 30 bus system. This is for each generator. As I mentioned earlier, there are 6 generators in the IEEE 30 bus system. Each generator is specified by these values. And there are some 4 transformers we considered. For the four transformers, this is the limits of this value, and the shunt compensator devices have these limits. Security constraint, that means the power outage values and the bus voltage are limited in between. That means those values, bus voltages must be in between minimum and maximum values of this. So these are the constraints related to the IEEE 30 bus. Okay, so under these constraints, the fuel cost must be minimized. So now the final objective function formulation includes the minimum of the fuel cost plus penalty. Suppose if there is any violation of the constraint, whatever I have shown, if there is any violation of the generator constraints or transformer constraints, the penalty must be added to the fitness function. Can anyone tell me what would be the importance of this penalty? Why it is to be added to the fitness function? So far, just I have shown what is the function of the minimum of fuel cost. Yes, please.
To avoid the unscheduled transactions or unscheduled drawal of power, and to avoid cascading.
Okay, not exactly. So actually, penalty is related to the violation of constraints. Suppose while finding the optimized values of this generator, that means the output powers or whatever I mentioned. So while finding the optimized 24 decision values, if there is any violation, then optimization algorithm should not stop there. So if there is any constraint violation, this penalty is added to this means fitness function. When the penalty is added, penalty is weighted by K, that is a penalty multiplication factor. When the penalty is added, the fitness function value suddenly rises. That means the optimization algorithm is looking for the minimum of the fitness function. Once the penalty is added, when the penalty is to be added, when there is a constraint violation. When there is a constraint violation, only the penalty is to be added. This is the penalty factor method. So according to this method, the penalty is to be added, then the optimization algorithm will skip this solution for the whatever the solution it has given for which the constraints are violated. Then once the penalty is added, that solution will be skipped and it will continue the search. So in order to continuing the optimization process, the penalty is to be added. If there is no penalty, then the optimization algorithm will give you the bad solution such that there is a violation in the constraints. So there must be some mechanism added to the fitness function if there is any violation in the constraints. So otherwise, the optimization algorithm, whatever we use for minimization of this fuel cost, cannot give the good solution. So that is the importance of adding the penalty to the fitness function. So this is the this objective function I will show in the MATLAB, how to implement this objective function for the IEEE 30 bus system, including penalty. Now these are the objective functions of other cases. In the second case, the objective is to enhance the stability of the network. Voltage stability of a power that is IEEE 30 bus system. So basically there may be some faults, there may be some collapse. So where L index is the value that represents the voltage collapse of the network. So if L index is 1, which represents there is a complete collapse of the voltage that network. If it is 0, then it represents the no load. I am not going to cover these cases for optimization. Just for the information, the case 2 will consider only one objective, that is the enhancement of the voltage stability of the network. Whereas in case 3, minimization of the emission alone. So for that, the objective function is this one. And whereas for case 4, there is a minimization of real power loss only. That is not fuel cost. Only the minimization of the real power loss. The objective function is this one. Whereas in case 5, there are two. There is only one object. There are two objectives. minimization of the fuel cost considering the wall point effect. I hope the power system engineers, they know what is wall point effect. You want me to explain what is wall point effect? So this wall point effect is very important. It affects the fuel cost. If there is a wall point effect, the relationship between the output power and the cost is non-linear, and it's not follows the straight line or some linear relation. If there is a wall point effect, then it's continuously oscillates. The output power of the generator continuously oscillates with respect to the cost. That means the cost varies with respect to the output power generation if there is a wall point effect. So that is to be minimized by using this optimization function, that is fitness function. In the case 6, there are two objectives included here. One is the minimization of the fuel cost and the minimization of the real power loss. In case 7, there are two objectives included: minimization of the fuel cost and voltage deviation. Case 8 consider two objectives: minimization of the fuel cost and enhancement of the voltage stability. The corresponding fitness function is given here. Whereas the case 9 consider the four objectives. One is the minimization of the fuel cost. This is already I have shown to you that we are going to discuss now. Fuel cost minimization, this is the cost function or the fitness function or objective function. There are different names given to it. And emission losses, minimization of the emission. That is, emission means the carbon emissions generated by the generator while it is generating the power, and voltage deviation and power loss. So all four objectives are considered in this case. This is a complex problem because this is a multi-objective problem, because there are four objectives to be fulfilled. Out of these four, we are going to take only one. The objective of the problem which we are going to discuss is minimization of the fuel cost, that is the optimization. And I have shown how to formulate the fitness function of the fuel cost alone. The fuel cost mainly depends on the power generation of the generators. That's why the fitness function includes AI, BI, CI are the cost coefficients of the generators and the output power generation of each generator. I equal to 1 to ng means the number of generators are 5. I equal to 1 to 5. So we have to consider 5 generators output power to minimize the fuel cost. So now coming, so far just I discussed the problem alone, not meta-heuristic technique what we are going to use. So the problem, I think it is clear to you. Any doubt in the problem? Can anyone please tell me? The problem to be tackled is clear to you, all of you? The problem to be tackled is clear. Now, the important thing is the optimization algorithm which we are going to apply to tackle the problem. So the optimization algorithm which we are going to discuss here is social group optimization. So basically, it was proposed by Suresh Satapathy and Anima in the year 2016. This is based on the human interactions. How these human interactions help individuals to gain the knowledge to solve the problem. For example, if you consider a group of people, the individuals have the different, every individual has a different knowledge levels. Suppose there is a problem. So the problem to be solved, the problem is to be solved optimally with minimum effort and maximum profit. So there is one problem in the society. That problem is to be tackled optimally. That means with minimum effort, such that it should give the maximum profit. So how to tackle it? So there are some group of people. So for example, there are 10 people. So the 10 people have the different knowledge levels. So they interact with each other to solve the problem. So initially the 10 people have the 10 different solutions to tackle the same problem. So those solutions may not be optimum. Some solutions may have the maximum fuel to be used, maximum effort to be used. Okay, there may be no benefit to get the solution. So the 10 people will interact with each other. They will share the knowledge so that the knowledge levels can be changed. So there is a changing of the knowledge levels. Initially, the 10 people have some different knowledge levels. When they interact with each other, when there is a sharing of the knowledge, they will gain some knowledge. Accordingly, they will give the different solutions for the same problem. So that means whatever the initial solutions the people have, that will be updated based on the interaction. So that interaction is modeled mathematically like improving phase, acquiring phase. There are two important steps in the social group optimization: improving phase, acquiring phase. In the improving phase, the people will interact with the leader. That means we have out of 10 people, there will be one leader. That means the one person will have the good knowledge, more intelligence. So that person can be considered as a leader. So based on the leader's knowledge, the other people will gain the knowledge, will get the various information related to the problem. So that means that is the improving phase. They will improve their knowledge levels. That is the improving phase. That means the solutions will be updated. And in the acquiring phase also, the solutions will be updated. That means whatever in any of the meta heuristic optimization algorithm, the solutions must be updated stage by stage. Then only we will get the best solution out of all the combinations. Initially, there are 10 random solutions. Stage by stage, the solutions are to be improved to get the better solution. Out of 10, we have to pick only one solution that should be the best solution. So for that, we have to do the search mechanism. In the social group optimization, they have used two important steps: improving phase and acquiring phase. Okay. So just these are the steps involved. Let me explain the first step: initialization. So in the initialization, we give the dimensions, population size, and the number of iterations. So after initialization, the fitness evaluation and determine the leader. Okay, I will explain through some example here. Okay, so this is the initialization. So initially we have to generate the initialization vector. Maybe I will explain these steps. Okay, for the same problem, if you see here, because of the time constraint, I am going little faster here. So IEEE 30 bus system, how many decision variables are there? There are 24 decision variables, as I mentioned earlier, right? So these 24 decision variables, we consider the population size as 10. So initially we considered 10 solutions. You can see here, each row represents the solution. The first row represents one solution to minimize the fuel cost. So out of these 24 values, the first 5 represent what? Can anyone answer? What are the first 5 values represent in the each row?
Generator.
Exactly, the generator output power. So the first solution, if you see 25.85, it must be in between lower bound and upper bound, 20 and 80. So like that, we considered 10 different solutions. These are the random solutions. So population size equal to 10 means, for the understanding sake, for the simplification only, I have considered 10. It can be more than 10 also. We can consider the population size as 25, 50, 100, as per our wish. If the population size increases, the computational time of the algorithm increases. So for understanding sake, I have considered only the population size as 10. We have considered initially there are 10 solutions for the given problem, 10 different combinations of the decision variables to minimize the fuel cost, which is the objective. Right. So this is the first initialization of the SGO. In the second step, that is called improving phase. The second step involved in the SGO is identifying the leader. Now what we have to do, these values are to be substituted in the fitness function. The fitness function is evaluated like A1 plus B1 PZ1 plus C1 PZ1 square plus A2 plus A2B. So the A1, B1, C1 are the cost coefficients which are already given in the IEEE 30 in the literature for IEEE 30 bus system. We can directly use in the program. So by substituting A, B, C and these values are PG1, PG2, PG3, PG4, PG5. After substitution of these values, we will get the fitness value as 1200, 2000, 3000, so on. So once you substitute these initial population members in the fitness function, we will get these fitness values as 2000. For the first population member, the fitness value is 2000. For the second population member, fitness value is 3000, and so on. Now, how to identify the leader of among all these population members? there are 10 population members. The population member which gives the minimum fitness value is identified as a leader as per the SGO. Are you getting the point? So what does it mean? He is the person who is having more knowledge compared to the other persons. We have considered 10 persons in a group. The person who is having more knowledge gives the minimum value of fitness as per the formulation. So this can be considered as a leader. So this is the improving phase. First, in the improving phase, we have to identify the leader of the population members. In the second, next step involved here is we have to update the values of these decision variables by using this equation, that is x nu equal to s into x old plus random into leader minus x old. X old means the previous one. These are all the x old values. So S is the only one tuning parameter that is present in the social group optimization, that is called self introspection parameter. This is called a tuning parameter like cognitive and social group and inertial weight parameter in the PSO. In the social group optimization, there is one parameter that is self-tuning parameter, self-introspection parameter. This is the typical feature of this algorithm, because this algorithm has only one control parameter or the tuning parameter, that is S. Its value lies between 0 and 1. After a lot of research people have done, in the base paper of SGO, they have mentioned that empirically they have selected the value of S as 0.2. So they have taken S equal to 0.2. When the S equal to 0.2, they have obtained the good solutions for the problems, whatever they tackle. So the X nu is calculated for each member. You can see S is taken as 0.2, X nu equal to S is 0.2 and X old. For example, this population member is to be changed. So this is this population member, that means this solution is to be changed to the new one. So with respect to the leader, so actually in this improving phase, every member will interact with the leader because the leader is having more knowledge. When every member is interacted with the leader, their knowledge levels will change. How to represent the changing of the knowledge level? By changing the solutions, that's all. That is equal to the changing of the solution. So they are updating the knowledge levels. Each population member is updating the knowledge levels after interaction with the leader. When they interact with the leader, these values will change. That is nothing but the changing of the solution. So once the X nu values are calculated for each and every member, you will get the new different population size. Population members, you will get the new population members. And again, those values are to be substituted. So, right. Here one condition is to be satisfied. Suppose if the fitness value of the new member is less than that of the fitness of the old member, then X nu is to be retained, or X old is to be replaced by X nu. Suppose if the fitness value of the new member is greater than the fitness value of the old member, then F old is to be retained, X nu is to be discarded. This is the process which we have to follow. So in the acquiring phase, every member will interact randomly with the other member. Every member will interact randomly with the other member. Suppose in the 10 members group, the first member will interact with the 9th member. If the 9th member is having more knowledge than the first member, then he gives the knowledge to the first member, then his knowledge levels are updated. Knowledge level updation is nothing but the solution updation. In every iteration, in every step of the algorithm, the population must be updated. That means the solution must be updated. That we are looking for. Every solution must be updated in every step of the algorithm. So in the acquiring phase, under the supervision of the leader, every member updates their knowledge. That means the solutions are updated based on these two equations. Suppose XR is the random member. If the random member is having the more knowledge than the old member, then second equation is to be used. If the old member is having more knowledge compared to the random member, the first equation is to be used. Here rand1 and rand2 are some random values which are to be selected between 0 and 1. So in this way, in the acquiring phase, again the population is changed. That means the population is changed twice in the social group optimization, whereas in the PSO, population is changed only once. After velocity updation, only the population is changed. Population change means the values are changed when compared to the initialization. So again, the fitness values are to be calculated. After improving and acquiring phase, the fitness values are to be calculated. Now, whichever member gives the minimum fitness value, that solution can be considered as that particular member is considered as a solution. Okay. Now here, if you see 1200 is the fitness value. So the one which is highlighted with the red color can be considered as a solution, which is an optimal solution which minimizes the fuel cost of the IEEE 30 bus system, such that the first generator gives 77.45 megawatts power, 42.73 megawatts power by second generator, like that. So this is the optimal combination of all 24 decision variables, whatever we considered in the formulation of the fitness function, are obtained based on the social group optimization. Okay. So in this way, there are 6 steps what I have mentioned. See here, these are the 6 steps. Now you can see here. First one is initialization, whatever I have shown. Initially, we will generate the 10 population members, 10 or more than 10, depending on the population size we select. After that, fitness value is to be calculated, and we have to determine the ladder. There are 2 improving phase. In the improving phase, the members will get the knowledge from the ladder, so that their knowledge levels are changed, so that the fitness values are changed. So those fitness values are to be calculated. In the acquiring phase, again, the members will interact randomly with the another member. The difference between improving phase and acquiring phase is, in improving phase, every member will interact with only ladder. But in the acquiring phase, every member will interact randomly with the other member of the group. Okay, so then they will gain the knowledge, but under the supervision of the leader. So in both these phases, the population members are updated, their knowledge levels are updated, the solutions are updated. Finally, we will calculate the fitness. So the fitness evaluations are more in the SGO. So finally, whatever the fitness values we calculated, based on that, the solution is selected. So in this way, the SGO works. So this is about SGO and the comparison of all the algorithms with respect to the tuning parameters what they use. In PSO, it uses 3 control parameters, that is social component, cognitive component, inertial component. Genetic algorithm uses 2 parameters, crossover probability, mutation probability, whereas differential evolution algorithm uses these scaling parameters or tuning parameters. And Gray Wolf optimizer uses only 1 tuning parameter. SGO uses only 1 tuning parameter. This is to be selected. Self-introspection parameter. This is to be selected point. These values are selected for comparison purpose. Same problem is tackled with PSO, GA, DE, Gray Wolf optimizer, SGO. I am going to show the results within 10 to 15 minutes. So SGO is applied for the algorithm, for the problem to be tackled. So these are the specifications and are the running criteria. So a number of iterations are taken as 500, and the number of fitness evaluations are 25,000. Population size, for example, population size is taken as 50 for genetic algorithm, particle swarm optimization, differential evaluation, Gray Wolf optimizers. So for 50, number of iterations are 500. That means 50 into 500, there will be 25,000 fitness evaluations. Every time, 25,000 times the fitness values are calculated for these algorithms. Even for social group optimization, the difference between social group and other algorithms is, in the SGO, the population is updated 2 times. So that's why population size is taken as 25. 25 into 2, 50 into 500, that is 25,000 number of fitness evaluations. So this is the running criteria. For the understanding sake, these results I will show at the end after showing the MATLAB code. So almost we are at the end of the presentation. So, okay, first let me explain this results. We have applied genetic algorithm for the IEEE 30 bus system to minimize the fuel cost, whatever the fitness function I have shown. PSO, differential evaluation, Gray Wolf optimizer, SGO. If you see here, the fitness value, that is the fuel cost dollars per hour, is obtained as 802.72472. So this is the fitness value when SGO is applied to the same problem. You can see here the fuel cost is minimized compared to genetic algorithm, PSO, DE, and GL. So this particular slide shows the importance or the accuracy of the SGO when it is tackled with optimal power flow problem, that is IEEE 30 bus system. The emissions are also minimum, so 0.36952 tons per hour. So this much emission only generated by the generators, and power loss is also minimum. Not minimum, actually, this is basically we have not minimized the emission and power loss. We have only minimized the fuel cost. So these values are just calculated for the values of what we obtained. So power loss is 9.7, and the voltage deviation is this much, and L index, that is the voltage stability of the entire IEEE 30 bus network, is 0.14426, and the fitness is 802. So this is for case 2. We have considered only case 1. For case 2 is the minimization of the emission. You can see here emission value is very minimum, so 0.3. And case 3, case 4, case 5, just I will I will share this PPT with the coordinators. Just you can go through the case 2, case 3, case 4, whatever I explained in the previous slides. So case 1 is related to the objective function what I discussed. Okay. So these are the results of case 5, case 6, case 7, case 8, and 9. And these are the statistical results. We have run the same program, same MATLAB program 30 times, and we have obtained the best fitness value, worst fitness value, mean value, and standard deviation. If you can see that SGO shows the best standard deviation. So the standard deviation is very minimum. So the standard deviation of social group optimization is very small, that is 0.4, which represents the good accuracy of the SGO. It is performing very well. It has provided the good solution. It has minimized the fuel cost effectively under all the constraints. That is the meaning of minimum standard deviation. Okay, like that for case 2 to case 9 are given here. So just I will quickly go through the MATLAB code. So in order to execute, I will explain the code in few minutes, and after that I will run the code, and I will show the results.
Hello, sir.
Yes, please.
Sir, in this optimization technique, the S value is chosen at 0.2 and somewhere that 0.5. That means S value is always 0 to 1, I think. So if some reviewer asking what is the right answer to say why were taken like that 0.2?
Self-introspection parameter, right?
Yeah.
So self-introspection parameter is selected as 0.2. That is the empirical value given by the proposer. Actually, the SGO was proposed by Suresh Satpathy in the year 2016. Yeah. After many trials, empirically he has given the value, because when S equal to 0.2, then only the problems are giving the better solutions. If the S equal to other than 0.2, then it fails to give the optimal solution. Suppose if S equal to 1, then there is no updation of the knowledge. Are you getting the point? If you see the equation, there is no updation of the knowledge. So as per the fitness function, okay, right. So this is the initialization, right? So you can see in the improving phase, there is a S factor. Yes. So if S equal to 1, X new equal to X old, that's all. That means there is no updation. So S must be as small as possible, then only there will be better exploration and exploitation. Better exploration will take place when S is minimum. Okay, yes, S should not be 0. If S equal to 0, the position would be 0. That's why the value of S is to be selected in such a way that the solution is the better solution. Okay.
That means we cannot say 0 to 1.
Actually, he mentioned, the proposer mentioned it should be between 0 to 1, but the empirically he has given the value as 0.2.
Yeah.
Okay, so you can mention that 0 for 0.2, this particular algorithm gives the better solution.
Okay, sir.
Right,
Thanks.
sir? Okay,
Yeah,
so Actually, in order to run this particular MATLAB code, we have to install the mat power. So this is mat power is the one program which includes all the data related to the IEEE 30 and other bus systems. So without this, the algorithm won't work. So many of the instructions, whatever used in the algorithm, takes the data from this mat power. Okay, so first we have to open this one. If required, I will give this data also. So first you have to open the MATLAB. After that, you have to install this. Okay, let me explain once again. So just after open, just you go to the location of that IEEE mat power, open the mat power folder and select install mat power and select and open this one. So already it is opened here. So after opening this install mat power code, you just please execute it. When you execute, it will prompt you to change the folder. Just you write change folder and please enter your selection, that is the default 2. Do modify the MATLAB path. So 2, enter 2 and hit any key so that it will be installed. Mat power is must to run these programs because IEEE 30 bus is having lot of data. The internal data, lot of internal data is required to use that IEEE 30 bus related problems in this particular scenario. Okay, so this mat power is very important and it is must to install before running the code, because it includes all the data related to the bus. That means there are various branches, there are various devices present in the IEEE 30 bus system. So in order to use that fitness function evaluation, we must use the proper data. After that, there is a main function, right? So now let me show this one. So this is the MATLAB code of the algorithm. So you can see here, initially there is initialization. So we have taken the optimal power flow problem, for which I have selected the population size as 25. What does it mean? So there are 25 initial solutions. Population size equal to 25 means there are 25 initial solutions. Out of 25, we have to select the best one. So these 25, every time their 25 solutions will update based on the improving and acquiring phase of the algorithm, that is social group optimization. Here the termination criteria is selected as 100 iterations. This program will execute 100 times and it will give you the output value. So 100 times it will execute, 100 iterations it will take. And this is the objective function, fitness function or objective function or cost function. Fitness function is written as a separate function file that is named as pflow, that I will show you. This pflow includes the formulation of the fitness function, whatever I have shown, that is sigma I equal to 1 to ng ai plus bi pgi plus ci pgi square, that is to be formulated. And I have kept it as a function, like function that is named as pflow. So that is the fitness function. And as I mentioned in the initialization, we have to give the lower bound values, upper bound values of each and every decision variable. We have selected 24 decision variables. These are the upper and lower bound values. The dimension of the problem is 24. It is the 24 dimension parameter. So after that, this particular initialization includes the objective function. I will show this fitness function in the separate file. And after that, we have to apply the optimization algorithm, that is social group optimization, to this objective function. So what algorithm we have applied? SGO. This SGO is again another function. We'll get the results. So finally, we will get the best fitness value, best fuel cost value, emission, P loss, voltage deviation, L index, and the 20 major decision variables. After 100 iterations, we will get it. Okay, right. Now I will show the fitness function for the OPF. Just go to the folder and here pflow. So this is our fitness function. Right. So this is our fitness function. Right. So this is all the data related to the bus. What I mentioned, cost coefficients, all the cost coefficients and the bus line voltages, that is bus voltages, all the voltages are data related to all those things are initialized here. So these things it will load from the mat power. Okay. So now this is the main function. This is the fuel cost. This is called a fitness function. So if you recall, there is a sum of sigma ai, that is the first cost coefficient, ai plus b, that is ai means a1, a2, a3, a4 up to a5. So that is ai plus bi pg1, that is power generation of the first generator, and cost coefficient c, this is cost coefficient c into pg square. So this is the cost function. Just I will show here formulation of this one. You can see here. Just right. So this is fitness function, right? You are able to see here. So AI plus BI PG1 plus CI PG square. So this is to be implemented through MATLAB. So the corresponding MATLAB instruction is this one. Okay, so be careful of sequencing coefficients because coefficient 1 is A1. So already cost coefficient is already defined, that will be taken from the mat power. Okay, already it is defined. So this is the cost function. Now we have to add the penalty. I already mentioned what is the importance of penalty. So all the penalty, so you can see in the constraints, these are the constraints. There are generator constraints, transformer constraints, shunt compensator constraints, and security constraints. So all these constraints are represented as errors. If there is any deviation, for example, VZ1 is less than V minimum, or if VZ is greater than V max, that is the constraint violation. When we can say that the constraint is violated? Can anyone answer? When we can say that the constraint is violated? If the generated voltage, generator output voltage is greater than V max or less than V minimum, then it is constraint is violated. If the generated power is less than P minimum or greater than P max, then constraint is violated. So greater than P max or less than P minimum is formulated as an error. Okay. So all those values are to be given. V max, V minimum, all these values are to be taken from the mat power. Okay. So for IEEE 30 bus, for every generator, the V max and V minimum are already defined. So all those values are already given here. So in these V max line, V minimum, this is the data related to the constraints. So finally, this is the error equation. PGS, this is the checking of constraint violation. This error is related to the equality constraint. So as you see here, there are two constraints, equality constraints, inequality constraints. If there is a violation of the equality constraints, that is represented by the error. So this PGS error represents the equality error constraint. So every time this PGS error is calculated. Next, after that, inequality constraints are also calculated. So the error, these are all the errors corresponding to the constraints. So all these errors are added to this fitness function. See here. So calculation of the penalty. So this error is added. So finally, as I have shown earlier, so now this is the finalized objective function to be used for the optimization algorithm. So in the optimization algorithm, the penalty is to be added. So this penalty is to be added based on the constraints. This K into penalty is responsible for the constraints violation. If there is any violation, then penalty is added. If there is no violation, no penalty can be added. Okay. So this minimum of fuel cost is the main objective. Okay. Because whatever the optimization algorithm we apply to the objective function, it must satisfy all the constraints. So the final objective function is fuel cost plus total error, that is the penalty, K into penalty. So this is the fitness function of the case 1. Okay, so just I will all cases are shown here, but we will execute only one. So because these are the fitness functions of all the cases, but I am going to explain only one case. Right. So this is about fitness function implementation. Later in the main program, if you see, fitness is already, pre-flow is already explained. Now SGO, what is SGO? So SGO is written in the separate file that I am opening now. So this is social group optimization. So in social group optimization, you can see here initialization of the positions of the search agents. I have explained 6 steps. So all those 6 steps are given here. First, you have to give the length, that is the dimensions, how many dimensions are there, and population size, so that is NP. So there are different steps here. Evaluation of the objective function. So this will evaluate the objective function, that is FOBJ. FOBJ is the evaluation, the fitness function, which is defined in the main program. So in the main program, it is given FOBJ is nothing but the fitness function. So each time it will calculate here. So it will calculate after substitution of the solutions in this fitness function. Each time it will calculate the fitness value. Based on the working of the SGO, it will perform the improving phase and acquiring phase, ensuring that the current member is not the partner based on some conditions. If the fitness of the old member is less than that of the new member, the old member is retained. If the fitness value of the old member is greater than the fitness of the new member, then the new member is replaced by the new member is replaced in the old member. Okay, old member is replaced by the new member. So in this way, the population is updated using this code. So finally, we will get, it will be SGO execution is terminated once the number of iterations specified is completed. Okay. So now I am running this code. This is the main program. When I run this one, it will ask you to change the folder of MATLAB editor. So now in the So SGO is optimizing the OPF. At every iteration, you can see here, at every iteration, the best fitness value it is showing. So initially, the best fitness value is very high. So initially, its value is very high. After every iteration, the fitness value is improving. You can see it is because it's a minimization problem. After every iteration, the fitness value is improving and it's reducing. So this process will go up to how many iterations? Can anyone answer? This process goes up to how many iterations? 100. We have given 100 as a maximum iterations in the problem. So there are 100 iterations. After 100 iterations, the execution will stop, and that will give you the optimized values of the problem. So 93, still that fitness function is minimized, see here, right? So after 100th iteration, so you will see the better results of that optimization algorithm. The best fitness value is this one. The fuel cost is 807. Emission, power loss, voltage deviation, and voltage stability, these are not optimized, but based on the values given, these are calculated. These are not the optimized values, because in the formulation of the fitness function, we have not taken this as an objective. Only the fuel cost we have taken as an objective. Okay. So this emission, P loss, VD are not the optimized values. As I mentioned at the beginning, these 24 values, the 24 decision variables are shown. Okay. So in this way, we can execute that social group optimization, and we can get the results. Any doubt here? I have gone fastly, it seems.
Participants, do you have any doubt? Sir, I think you can continue.
Right, sir. So within 2 to 3 minutes, I am going to conclude this presentation. Okay. So this particular process is to be done 30 times. I have shown one time, 100 iterations are completed. We have obtained this result. So this fitness value is obtained for one run. So in order to check the accuracy, precision and compatibility of the algorithm, each algorithm is to be tested as many as times. So we have run the program 30 times and we have obtained the 30 different fitness values, and we have taken the average of them, that is the best of all those 30 values we have considered here, that means in SGO only, and worst of that value, mean of all those 30 values, and standard deviation. So this particular statistical analysis will give us the performance of the algorithm. So in what way? If the standard deviation is less for any algorithm, which represents it's very good, the deviation among the fitness values is very minimal. So that is the way we have to analyze the performance of the algorithm. So the performance of the algorithms are analyzed statistically by finding the best, worst, mean, standard deviation of the results. So I have shown only one run. In this way, 30 times if you run, you will get, because the algorithm is of stochastic in nature, probabilistic in nature, it gives 30 different values. If all the 30 different values are close to each other, then standard deviation is almost less. That is the meaning of standard deviation. So in this way, we can execute, or we can implement the social group optimization to tackle IEEE 30 bus problem to achieve the minimum fuel fuel cost objective. Okay. So with this, the implementation part is completed. So coming to the conclusion, just we have discussed the meta heuristic optimization and its importance to the power systems. And just I have given the brief overview of the three classical paradigms of social genetic algorithm, particle swarm optimization, and differential evolution, which already you learned from the previous sessions. And after that, we discussed the working of SGO and formulation of the mathematical model of IEEE 30 bus system. At the end, I have shown the MATLAB implementation of social group optimization and mathematical representation, how the mathematical modeling of the taken problem using MATLAB, and we have seen the results. We have compared with other algorithms to see the performance of the proposed algorithm here, that is SGO, not proposed by us, proposed by someone else, but here we have taken for explanation. So SGO performance is compared with 4 more algorithms. So SGO outperforms compared to other algorithms. So the conclusion is this one, just you can go through it. And there is a future scope. The SGO cannot, not only it can be applied in the electrical systems, it can be applied in the other domains of engineering. And people have used SGO for detection of COVID-19, and people have used it for X-ray images and so on. Okay. So I hope you understood a little bit. I will share this PPT with all the coordinators of this program.
Start with the STD code.
Thank you very much.
+91. The 1091.
So with this, the presentation
Thank you,
is
sir.
completed, sir.
Thank you very much.
Okay.
Yes, thank you so much, sir. Dear participants, if you have any queries to ask, sir is there. You can freely ask your questions to sir. I think sir has very nicely explained all the parameters. So still, if you find any question, you can ask.
I will share the PPT and MATLAB code to all the participants. So
Okay,
all
sir.
of you, please go through it once. If you find any difficulty in understanding, you can please write a mail to me. So
Sure,
I request all the participants to take my mail ID from the organizers, and you can take the phone number also if you have any difficulty in understanding any of the things, because I have rushed my presentation, because in order to complete within 2 hours, I have taken exactly 2 hours to complete the presentation, because initially I lost 10 minutes that I have compensated at the end.
Good afternoon, sir.
Very good afternoon.
First of all, I would like to thanks for the resource person, because this is a very vast subject. Generation plant is a very vast subject,
Yes.
and you have explained in 2 hours very nicely and easy way.
Right.
But I am not able to understand the total, because the subject is very large.
Yes, exactly.
Uh, for the we have got interest because it is related with our power generation.
Power system. Right. Right.
I would like to share my experience about the generating plant. I work at 210 megawatt
Okay.
TPS.
Okay.
So these parameters are very large. We have to control the capability curve, reactive power,
Exactly.
like voltage,
Yes.
then flux. We have to control the flux. Then synchronization because our machine is synchronized with the grid.
Yes. Yes.
So this is very. I would like to know the more things, but it is not 2 hours to understand all the things.
It's very difficult to cover all the things in 2 hours lecture because there are 3 to 4 subjects included in this topic. First one is power system. Power system is a vast area because you must know all the basics of the power system, and optimization is another area which we have covered here a little bit, and the MATLAB code also we have covered. So as you mentioned, I think Mr. Subhash Anokar, as you mentioned, it is very difficult and it's very challenging to cover everything in one presentation. So we can cut and we can discuss separately if required in future.
Because there are more interlocks. There are water treatment plant, then control system, then
Exactly. Exactly.
relays, then operation and management, then
Yes. Yes.
coal handling plant. There are very different departments. Then instrumentation, turbine maintenance,
Exactly.
and every is having interlock with each other.
Yes. Exactly. Exactly. So that's why
Thank you.
while formulating the problem, that is while formulating the mathematical model of the problem, it is very important to consider all the constraints, all the features of that particular problem. Then only we can able to formulate. If the mathematical model, whatever the fitness function I have shown to you, if we fail to formulate properly, then we cannot get good solution whatever the algorithm we use. Are you getting the point, audience?
We want more session to know how to formulate the problem because
Exactly.
it is
Exactly. The mathematical model, the formulation of mathematical model is only the important thing. So we can, once the mathematical model is formulated effectively and accurately, then if you apply any algorithm, we will get the better solution. If the mathematical model is not good, whatever the good algorithm you apply, you will not get the good solution.
okay,
So,
sir. Thank you very
right.
much once
Right.
again.
Right, sir. Right.
Yes. Any other participants want to share something? Thank you, Subhash Anokar, sir.
Thank you, sir.
Any other participant wants to ask any question? I think Narayan sir,
Yeah.
shall we conclude?
Sure, sir. Sure.
Yeah.
Sure.
So thank you so much, sir. Thank you so much for your very nice talk on the topic. Optimization tools and techniques for electric systems. I think you have covered many areas like the metaistic optimization and its contributions,
Yes.
a brief overview of 3 classical paradigms of optimization, working overview of SGO, and finally the MATLAB implementation which you have shared.
Yes.
It definitely will help our participants to do the research in the topic.
Yes.
So I, from my bottom of heart, I just want to say thank you so much, Narayan sir,
Right.
and thank you very much all the participants for your patience listening. So with the permission from the speaker, I just want to conclude today's last talk of this STTP.
Thank you very much,
Sir,
sir.
one more thing, sir.
Aparna, madam.
Participants, if you are interested to give your feedback on this STTP, tomorrow we will be having valedictory function. So please come forward and give us suggestions for our better improvement or for betterment of the further future conduction of such kind of STTPs. So please participants, and thank you Narayana sir. This
Right.
session was extremely nice and everyone will definitely appreciate sir. You have
Thank
taken
you.
lot of
Thank you very much,
efforts.
madam. Thank
You
you very
tried
much,
to
madam.
explain us from the bottom of heart and the
Yes, madam.
depth of that
Right.
algorithm so nicely. Thank you
Okay.
very much sir.
Right.
So participants, please be with us. Write your names if you are interested to give your feedback, your suggestions, because your feedback and suggestions really matters for us for betterment to conduct such kind of STTPs in future also. So thank you, sir.
Thank
Thank
you,
you, my
madam.
colleague Gadge sir. Thank you, all participants. And thank you, both HODs from our colleges, Dr. Dote sir and Professor Shahakar sir, for which always motivates us to conduct such type of STTPs. So thank you, sir.
Thank you very much, madam, for giving me this wonderful opportunity to share some of the concepts related to optimization techniques for electrical systems. Thank you very much, everyone.
Yeah, thank you, sir.
Right.